Simeo, May 2020. Student Competition Warehouse Picking Strategy. Prepared by Quarantine with Simeo team. This is a simulation of my Back Distribution Center, MDC, which stores footwear and apparel items, shipping out to the different regions. As an increase in orders and diversification, warehouse planners are looking to improve the picking strategies to meet their service goals. These are their objectives. First, want to use simulation to improve the wave planning process. Second, to meet a 99% service level or consistently ensures that 99% of orders are fulfilled on time. Third, to find optimizes labor utilization and minimize missed customer delivery date by improving the wave planning and picking strategies. These are our assumptions. First, footwear and apparels will enter the delivery source and will be categorized into sales channel and wave type respectively. Then, order will be grouped following the conditions at the grouping and waiting node. After that, an MHE will be assigned the wave and go to the SKU location to pick orders with the type and quantity required in each wave. After finishing picking, dedicated single wave and dedicated case wave is directly sent to single packing area and case manifest area respectively. Others are transferred to stage and to conveyor. The conveyor can be loaded only one wave at a time, and orders are moved to standard shipping area. After packing process, all orders are sent to shipping area, preparing for distribution.
Deliveries SAR. This source is foreign create and batch process. When a delivery is created, we are setting components orders, batch them together, divide wave depend on sales channel and type of item by using process name separate wave, and then send them to the appropriate wave staging transfer node. Wave node enter process. We will check if a single delivery has quantity large enough to wave immediately, or if deliveries have already been packed at this node. It will transfer to input wave release server. If not, the delivery will park at this node. With due date every 24 hours process. We are checking every day at 12:15 a.m. If any orders are due in the next 24 hours. If so, rush them by firming the monitor event that will unpack their delivery via the wave node enter process. Wave release. When icon server is yellow, it's doing member output wave release enter process. By summing order quantity for all members that exit the system within a given delivery. If a new delivery is detected, update variables accordingly. Assign the previous delivery quantity to the output table with contents, and separate delivery entity to enter parents output wave release enter process and items entity. Item entity is add zone on label entity and set priority assigned by considering order type. If single type, priority first. If add one type, priority second. And if filter type, priority last before transferring to input priority server. When icon server is green, it's doing parents output wave release enter process. Begin adding row in wave contents table for each delivery that exit the system. Assign the wave code and delivery number to the new row in the table. Then check if wave release input buffer is empty. If so, check if there are any large order, then reset the early due date for that sales channel. Assign the summary wave information to the wave summary table. And following wave parents enter process that transfer delivery entity to parents node. In grouping process, if wave is single or case or multiple and any state is not full, we will decide wave following to the available space of chosen MHE, which is depend on capacity set process, and group them before MHE start. If wave is multiple or state is full and no space of MHE, we will transfer order to waiting node. Waiting node or wave that is parking at waiting node will transfer to grouping node after any state is not full or available MHE.
Combiner send MHE will receive the order from grouping node and process call MHE. We have to check tier of entity first and then call pallet jack from list for entity tier A and call lift truck for other tiers. Set the MHE is not available and see the picker from picker list. In process, send MHE exited. If it is the single entity, assign MHE destination to single packing. If it is the case, assign to case manifest. But if it is multi, go to process provide state first, set MHE destination to entities IO and restart MHE. For process provide state for multi-entity is a process for assign entity to stages. If the number of waves in that state equal the number of waves that entity will be done, entity will be sent to that state. After send MHE assign MHE to their destination. MHE go to separator at each state to separate entity and MHE. Input is process a variable MHE to set MHE a variable. For variable MHE at parent output, will go to sync MHE park to release a picker. At member output, we will send entity to node state 1, and that is the label shows numbers of waves in that state. At node state 1, transporters are inductions from induction list. Process state 1 enter is a process to receive orders until the state is full. If state 1 is not full, number of entity in state 1 will plus order quantity and wait until the state is full. We will start the induction. Node state 1 connect to node convey 1 with time part, which have a travel time is induction F from process efficiency induction. At node convey 1, process node conveyor 1 is checking the waiting entity in queue that induction already moved all of them on the conveyor. Then free state and release the induction. Conveyor finish at server standard picking, which processing time is entity's pack time. State 2 and state 3 will be the same process as state 1. For case manifest and single packing area, they are the same as separate state 1. MHE go to separator to separate entity and MHE. An entity will go to server case manifest or single packing, which processing time is entity's pack time. An entity will be sent to the last sync for ready to shipping.
When we finish 100% of running the model, we found some interesting criteria which can be further analyzed for the wavering and picking strategic improvement. Percent of orders completed on time equal 97.64%. Worker utilization equal 89.62% and pickers utilization equal 99.92%. MHE utilization, lift truck utilization equal 0.46% and pallet jack utilization equal 38.30%. Order time in system of footwear equal 641.53 minutes and apparel equal 622.34 minutes. After simulating several alternative improvements, we found some recommendations which are: 1. The optimal size of wave is 5,880. The wave size should depend on other attributes since some apparels require VAS, and the apparels cannot be waved as a case. Additionally, the unit locations can be another factor. If the items are far away, it takes more time for changing the MHE and pickers. The picking MHE constraints are also affecting the wave size. The order might not complete on time because of the lack of MHE. 2. Single picking should be waved together for more efficiency picking. As a result, the wave quantity of single waves seems to be low, so we should wave the single item together by referring a due date. Sales channel will not be considered in this case, and multi-item and case picks remain the same. 3. The minimum number of workers on picking team to ensure that at least 99% of orders are completed on time is more than 15. Result table shows that all of pickers have the scheduled utilization above 99%, which is extremely high, and if the number of orders increase, the current workers will not able to complete the task on time. The last one, the minimum number of MHE that is needed to meet the 99% service level goal is: pallet jack should have more than 16 and lift truck should have more than equal to from the result table.